So while you're converting these 2 points from polar to rectangular or from rectangular to polar, what tools are you using in your toolbox? Or from your toolbox, I should say. What's one of the 4 tools that you're using? That's one of the tools. Okay. Or r equals the square root of x squared plus y squared. That's 2 of the tools. Yep. One more.
Theta equals the inverse tangent.
Theta prime, the reference angle. Yep. And there's 2 conditions that we have with using inverse tangent of y over x. What are they?
Drop the negative.
Drop the negatives is one. And check the quadrant. Yep, check the quadrant to make sure you get it in the right quadrant. Okay? All right. First one, A. Is that rectangular to polar or is that polar to rectangular? Rectangular to polar. So that means, am I going to use blue or red? Because the blue ones go from rectangular to polar, right? And the red ones go from polar to rectangular. So I'm going to be using the blue ones. Okay? So that's going to tell me that my R value, whoops, taps the brakes. Why does it do this? I don't know why it does that. So R is going to equal the square root of 2 squared plus negative 2 squared. Okay? 2 squared is 4. Negative 2 squared is 4. 4 plus 4 is 8. So this is the square root of 8, which is 2 square roots of 2. Agree? Okay. Theta prime here is then going to equal the inverse tangent of 2 over 2, dropping the negative sign on the y. That gives me the inverse tangent of 1, which tells me then that that is 45 degrees. But where is the point? 2 comma negative 2? Quadrant 4. So that means that my theta is actually going to be 360 minus theta prime, which is 45, bad 5. Okay. So that's going to be 315 degrees. So my rectangular point written in polarness is going to be that. Now, if I wanted to change that over into 2 square roots of 2 comma 7 pi over 4, okay, if it said maybe on Friday's test, give all of your angles in radians, that's a possibility out there. Okay? Agree with that? Fantastic. Part B, rectangular to polar or polar to rectangular? Polar to rectangular. So this is going to say then that, whoop, tap the brakes again. Come on now. X is going to equal R times the cosine of oops, I almost put theta there. Of 2 pi over 3. The cosine of 2 pi over 3 from the unit circle is negative 1/2. 4 times negative 1/2 is negative 2. Y then is going to equal 4 times the sine of 2 pi over 3. The sine of 2 pi over 3 is the square root of 3 over 2. So that gives me 2 square roots of 3. No, because we're exact on the unit circle, so we're going to go exact in our answer. Okay? So that gives me this in in rectangularness of negative 2, 2 square roots of 3. Okay? Today, we're going to move away from points, and we're going to move to equations. And we're going to convert equations. Today, we're going to go from rectangular equations to polar equations. Tomorrow, we'll go from polar equations back to rectangular equations, and so on and so forth. Okay? So, a rectangular equation usually is y equals something, and that something is in terms of x. Oops, wrong button. There's that button. Okay. So we've got y equals something, or we've got x's and y's, but we normally have it written out as y equals, or f of x, which we replace sometimes as y. Okay? And then we would take those and we would plot our points x comma y. Right? And that's great. Okay? Pick some x's, plug it into our equation, get out some y values, plot those points, draw a nice smooth graph. Okay? Polar-wise, we look at polar equations, and we look at it as an r equals something, and that something is in terms of theta. Here, we plot points r comma theta. Okay. But here now we pick our theta, plug our theta into the equation, get out r. Okay, we do it a little backwards. Okay? So if I'm going to convert between those two, the first thing that I am going to do is I'm going to use my tools to eliminate x and y. So sometimes the tools, or I shouldn't say sometimes, the main tools that you're going to use 3 of them. The main ones that you're going to use are x equals r cosine of theta, y equals r sine of theta, and x squared plus y squared equals r squared. Those are the 3 main ones that you're going to use. Okay? Really, you could get by with just using x equals r cosine theta and y equals r sine of theta. But we can do x squared plus y squared equals r squared, just to shorten that up a little bit. Okay? Then, so we're going to use the tools to get rid of x and y. Then, we're going to use algebra to solve for r. Because remember, we want our final answer, we want it in r equals form. Okay, so we're going to manipulate our equations using our algebraic facts and algebraic logic to get our equation down into solving for r. Okay? Let's try one. So, the first one that I want to try is I want to change y equals 4 into a polar equation. Okay? Just out of curiosity, what does the graph of y equals 4 look like? It's a horizontal line. 4 up from the origin, right? Okay? So it looks 1, 2, 3, and 4. So it looks like that, right? Okay? If I were, and I shouldn't say if, when, in a couple of minutes, when we graph it in a polar equation, what's it going to look like?
I assume that it would be a circle at 4.
A circle? What's it going to look like? No. Rectangularly, it's a line, right? Horizontal, 4 up, above our origin. Polarly, what's it going to look like? FYI, it's a trick question. Why is it a trick question? No. If it looks anything else other than a horizontal line 4 up from the origin, we've done what to our problem? We've changed the problem. So this thing, when we graph it, had better look like 1, 2, 3, 4. It had better look like that. It had better look like a horizontal line 4 up from the pole. If it doesn't, we've done something totally wrong because we're saying we're changing this line into a line just in polar form. Okay? So, let's go about doing that, and then I'll verify those two graphs momentarily. Okay? So, y equals 4. What tool from our toolbox can we use?
Y equals r times the sine of theta.
And how would you think I'm going to use y equals r times the sine of theta?
Just put in, so then 4 equal r times theta.
So in place of y, we're going to put r times the sine of theta equals 4. I'm replacing y with what y is equal to. It's called substitution in algebra. You've done it hundreds of times. Right? Okay? Now, how does my answer need to look? R equals. So I got to get that equation to look like R equals. How am I going to do that? So I can divide both sides by the sine of theta. Agree? Have I done any funky math yet? We've substituted and we've divided is all we've done, right? Now, let's clean it up. Let's make it look pretty. Okay? Like my pink shirt today. Make it look pretty. How can I change this around to make it look pretty?
Four times the cosecant theta.
Bingo. 1 over the sine of theta is equal to the cosecant of theta. So that, ladies and gentlemen, is our prediction for the horizontal line at 4 straight up from the pole.
It's still a horizontal line. Why not just keep it in rectangle?
Because we don't do everything in rectangular. You know what I mean? Right now we're working in polar. So we got to figure out how to go from polar into rectangulars. Okay? Okay? Let's check it. So, I'll walk you through everything. So, I'm going to start with a graph. Yes? Okay? I need to change my, actually here, y equals 4. Boom, there it is. Horizontal line, y equals 4. Yes? Okay? Now, let's change this. What am I going to use for my entry type? Polar, because we're graphing polarly now. Just like when we were graphing with parametrics, now our entry point has changed. We've modified some things. Okay? So, r equals something, and that something that we had was 4 cosecant of theta. Horizontal line, 4 up from the pole. Okay? Logically wise, let's look at this one. If I were to plot some points here, if I pick some thetas, I'm going to pick 90 degrees here. We'll stay in degrees to make it easier. 90 degrees. What's the sine? And we'll go back to this blue equation. What's the sine at 90 degrees? 1, right? 4 divided by 1 is 4. So that gives me an R value of 4, which is right there. Let's go to another one. Let's go to 30 degrees. What's the sine at 30 degrees? One half. 4 divided by 1 half. Four divided by 1 half. 8. 4 times 1 half is 2. 4 divided by 1 half is 8. So what does that mean? Oops, I should have put that in a different color. Forgot I wanted to put that in a different color. So what does that mean? Out 8 rings, right? Okay, so there's 1, 2, 3, 4, 5, 6, 7, 8. Let's do 150 degrees. What's the sine at 150 degrees? 1/2, right? Which means 4 divided by 1/2 is 8. 1, 2, 3, 4, 5, 6, 7, 8. Let's get crazy. This is when you're going to need a calculator for. What's the sine of 1 degree? Or I should say 4 divided by the sine of 1 degree. 229.1? 0.1, so we'll call it 0.2, right? So what does that mean? So I'm barely above this, right? Right? There's about 1 degree, let's say, which means I've got to go 229 rings, which I know they can't see this on the interwebs, but that puts me right about here. Right? Okay. What about 0 degrees? What's the sine of 0 degrees? Sine of 0 is 0. 4 divided by 0 is undefined. Because I'm not horizontally out here. I'm 4 above that, right? So it won't be, I could never have 0 degrees. So that gives me a line. Okay? Next one. Let's do the same thing. Logically wise, what is the picture, the graph of 4x minus y equals 5? What is that picture? What is that graph? So you said y-intercept of -5. Okay, so that's down here. 1, 2, 3, 4, 5. I think I got that right. 1, 2. Yep. Okay, and then a slope of 4, right?
Yeah.
So up 4, right 1. Up 4, right 1. Up 4, right 1, and so on and so forth. Right? So that's what my end game should look like. Yes? Solve it for R. Agree with my first step? Yeah? So then you get 4r cosine of theta minus r sine of theta equals 5. Yes? I want to solve for what? R. How am I going to algebraically solve the left side, or solve this equation, for R? Algebraically, how am I going to do it? Because there's 2 of them. So I can't just put everything on one side. What do I have to do? Let's factor out an R. what's left over if I factor out an r? 4 cosine of theta minus sine of theta equals 5. Do I have it r equals yet? So how do I get it r equals?
Divide both sides by the 4 cosine theta minus sine theta.
So r is going to equal 5 divided by 4 cosine of theta minus sine of theta. Now, when I graph that, what should it be? What should it look like, I should say? Should look like my purple graph right there, right? Okay. Let's try it. So, new graph. Okay. So we said this was 4x minus 5. So that's what it should look like, right? Okay. So now let's go all polar on us. Oops, not window zoom. This one. Polar. Oops, tap the brakes. There we go. Whoa, whoa, whoa. There we go. Okay. We said 5 divided by 4 cosine of theta minus the sine of theta, right? So when I hit enter, it should replace this red line, correct? Shabam. Replaced it. With exactly the same thing. Huh? Yeah? What's up?
Because you're plotting like with a polar, why doesn't the graph change to look like the ones that we've been working with? Like,
It really is on there. It's just that the calculator doesn't change it to look like that. The calculator just keeps it in a rectangular grid. Okay, but it's graphing it polar-wise. Okay. All right. Try number 3. Just out of information-wise, this is a circle with a center at the origin and a radius of 3. You guys haven't learned conic sections yet, okay? But that's the equation of a circle centered at the origin with radius of 3. Okay? Polarity-wise, x squared plus y squared equals 9. What can I do in terms of my toolboxes or my tools that I can use? So this whole left side becomes r squared. Correct? Is that r equals though? Square rooted. So really, I should get r equals plus or minus 3. Correct? Okay, hold on. R equals positive 3. Says that I go 3 rings out, right? Start at my theta of 0, work myself around counterclockwise, and boom, done. Correct? r equals -3. What does that tell me I have to do? I go start over here at pi first, right? Work myself counterclockwise around and end over at pi. Gets the exact same graph, right? So in terms of polarity, we only need to have one of them because it would give us the exact same thing. You got to use some logic when you're switching into polar stuff. Okay? Have yourselves a